Snap has this kind of native kind of peer-to-peer configuration system. The idea is that you have a tribe that is like all your nodes, and then you have agreements, and a node can be a member of 0, 1, or many agreements. An agreement is like a configuration snippet. So you can say, okay, I'm going to create an agreement for my web frontend. And so in this agreement, I'm going to put a specific metrics collection configuration, like I want to get Apache configuration from var log httpd, and I also want to get the number of open sockets and this and that. And I will have another agreement for my hypervisors where I will graph like CPU utilization and temperature and whatever. And then I will have my nodes join the agreement that I want them to be in. So all my load balancers, I will have them load the agreement specifically for the load balancers. All my physical machine hypervisors will load the agreement for hypervisors, and so on and so on. So we need to run Snap on every node. And then I'm going to show you probably the worst Docker hack ever, because we need to get Snap running on every node, but on the host itself, not in a container. So what I'm going to do is I'm going to create a global service running on every node. And this global service will use SSH to connect back to the host and start Snap on the host. This looks like this. So I'm doing Docker service create -- name snapd mod global, and then I'm bind mounting the SSH key from the home directory into /SSH key. Then I use like a basic Alpine container. I install SSH client, and then I SSH back out of the container to the host. And then I execute sudo snapd with all the options I need to start this. Yeah, so the right way to do that would be to, for instance, use config management to say I want the Snap package to be installed on my machines, and I want the Snap service to be running and be started with all options, etc., etc. But as much as I don't advise doing that, I think it's really interesting to see that pattern, because at some point it can be useful for something else. Like sometimes, once you start to use the -- mod global and all that thing, I guarantee that at some point you're like, oh, I need to run that thing on all my machines. I wish I could run a command on all my nodes. And with a thing like that, you can do it pretty easily. All right. So I copy that, and a few seconds later, I should have snapd running on my whole cluster. I'm going to do snapctl member list, and I see, yep, node 1, 2, 3, 4, 5. Awesome. Now I'm going to create an agreement, which is basically the agreement for my Docker hosts. So snapctl agreement create Docker InfluxDB. So it tells me that it's an agreement that for now has 0 members, 0 plugins, 0 tasks. Then I'm going to have my 5 nodes join this agreement. So I'm going to do snapctl agreement join Docker InfluxDB node 1, 2, 3, 4, 5. Or you can copy paste that snippet, which is nicer because it takes all your nodes and it makes them join the agreement. And now if I do snapctl agreement list, it tells me that Docker InfluxDB has 5 members. Great. But it's still a useless agreement. There is nothing in it except the hosts. We need to have at least 1 container running on each node, but at this point that's already the case, so we can skip that. This is just like a safety slide, just in case you jump right in. Now we need to set up InfluxDB, which will be our time series database. InfluxDB exposes a bunch of ports, like there is the HTTP API, which is used to put data in InfluxDB and retrieve data. There is an admin web interface that we will also use a little bit. And then there is cluster communication, because InfluxDB can also have its own clustering mechanism. We won't use that there. So we are just going to publish the two ports we need, 8083 and 8386. So this looks like this. Docker service create -- name InfluxDB -- publish 8083 on 8083 -- publish 8086 on 8086 InfluxDB : 0.13. Make sure you have 0.13, because if you switch to 1.0, there are a few things that changed, and I guess the next time I will do this tutorial, Snap will be up to date with InfluxDB 1.0, and you will be able to use like 1.0 all the way. But for safety, I'm kind of pinning two versions that are known to work well. Okay, so now InfluxDB is running. So I'm going to connect to the web interface of InfluxDB. So I go to the IP address of any of my nodes on port 8083. And I'm going to create a database for Snap. Create database Snap. This looks like SQL, but it's not at all like SQL. It's just like, okay. And now I'm going to select the Snap database here. So I kind of do apologize in the sense that if you don't know InfluxDB at all, this is like pure magic. But I try to really kind of condense that to the very bare minimum steps that you have to do to get the whole thing working, and then you can expand and customize. All right. Then we are going to load the plugins that we need, so the Docker plugin and the InfluxDB publisher plugin. Okay, so snapctl plugin load /opt/snap/plugin snap plugin collector Docker. And this loaded the plugin on all my nodes, because I loaded the plugin in a node that was a member of an agreement, and so it was propagated to the other members of that agreement. I will do the same with snap plugin publisher InfluxDB. And now I will load the task, Docker InfluxDB JSON. So what is in that thing? So that one is in JSON on YAML, and it says, I want to collect CPU usage and memory usage every second, I think. Yep, every second, and send the result to localhost on port 8086. We are once again using the localhost global service, well, not global service, but localhost publish service trick, where since I published InfluxDB on port 8086, on any of my nodes, if I connect to localhost 8086, my traffic gets routed to InfluxDB. So snapctl task create -t docker influxdb.json. And now my task is running. So now I can go back to the web interface of InfluxDB, and I can do show measurements, and I can see two measurements, so that the equivalent of SQL tables, if you will. And now I can do like select star from, and then I put the name of a measurement between double quotes. And when I do that, it gives me a table of values. So I see like a timestamp, the ID of the container, the source is just like the host from which that comes from, and then the value. So I can see that I have values from node 1, node 2, node 3, node 4, node 5, and this is the ID of the container, but you can see I also have something special. Like I have a special ID called root, which is just like the container that contains all the other containers, to simplify things a little bit. It's the top level C group that contains all the other containers. So, okay, I have Snap collecting information on my containers and sending everything to InfluxDB, and I can see that information in InfluxDB, but I want to have like fancy graphs and dashboards. Fine, I'm going to deploy Grafana.